Everyone, welcome to this afternoon's session as part of the buildingSMART International Standards Summit, Valencia 2024. Thank you all for coming today. My name is Raj Woolley and I'll be your moderator. And this session is also moderated by David Delgado Andreu, Technical Coordinator at buildingSMART Spain, who's here to my right. Today's session is titled Open Source, Future Technologies and the Workforce. The speakers are on the screen for you there. Just to let you know, the schedule is for 90 minutes for the session, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible and on our YouTube platform within 6 to 8 weeks. Before I hand over to our speakers, I'd like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendees here in the room, please keep background noise to a minimum, and if you wish to make a comment or ask a question, please raise your hand and use the microphone. I'd also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, and the process for their adoption is transparent, and standards that are developed do not favour any particular provider and are open, non-binding, and accessible through all. Please take note of our antitrust code of conduct, and now I'll hand over to David.
Thank you. Thank you. So welcome everybody here. So the session that we have today, if you can go first before the disclaimer. Yeah, thank you here. You see the title, it's Open Source, Future Technologies and the Workforce, which maybe for some of you, even myself, well, but a lot of things in just a short title. But the idea here is to provide you a short tweet in which we can highlight how nowadays some of the technologies through the use of the open standards that we are currently using are shaping, let's say, the landscape that we are all surrounded in our industry, which is quite, complex, but also dynamic. And we say dynamic because, and especially some of the panelists here, they will, I hope, show how the current speed of these technologies are boosting us through this landscape, let's say. But at the same time, we have the core of our standards. That's why we have them here. And what we will have now, it's a short presentation, 10 minutes each of them, in which they will introduce themselves, and also they will provide us a background, enabling us to have a later discussion regarding all this. We hope that it's as interactive as possible, because, we are also glad that this room is quite full. So I think that it will be a very nice discussion. So yeah, let's start. The order is, we made a sandwich, let's say. We start with open source, and we will finish with open source again, but in the middle, because it's a lot, we have open standards, but open standards in the end are across all of them. So we will start with Neil. Probably some of you already know him, Neil Peterson, so please.
All right, so my name is Neil Peterson. I'm the president of Open Design Alliance. So we are a nonprofit technology consortium that provides component software for interoperability purposes. I don't know if you saw my presentation yesterday, but I talked about how most of the CAD and BIM industry are using our technology to read various file formats, IFC, Revit, DWG. And today I want to talk on a little different thread, innovative and sustainable BIM development. So our use, our software includes use of extensive use of open source software. We currently use 50 open source libraries in our product line. And we use it for a lot of things, font rendering, image processing, XML processing, compression algorithms, ZLive, point cloud processing, PDF file processing. Open source software is hugely enabling for the work that we do, and correspondingly for the products that use our software. Across the board, all the vendors in the CAD industry are benefiting tremendously from all of these low-level open source libraries. But open source has limitations. So our company actually, we don't have an open source business model. We have a source available, but it's not open source. And I'd like to talk a little bit from our perspective, what are the limitations of open source projects in this industry? And so just to give a couple of examples, we got into IFC development just 5 years ago. And one of the components that you need if you want to visualize IFC is a geometry kernel, a solid modeler. And if you go out into the open source market, you'll find that there isn't a good one available. A geometry kernel, there's Parasol, there's ACES, there's 4 or 5 commercial kernels. So Systems has one. There's 4 or 5 available on the market. They're all really expensive. They work really well. They've been developed over the course of the last 30 years. They've been carefully honed and tweaked, and they're good. And there isn't a comparable open source project available. So there are some open source modelers. There's one called Open Cascade, and we evaluated that, and it didn't do what we needed for all of our use cases. And it was interesting because even though it's open source, we have source code available for this product, we felt that we couldn't adapt it to our needs with any reasonable amount of resources. And so instead, we are actually developing our own geometry kernel so that we can customize it to meet our needs. The open source project, the support wasn't there. The code doesn't do what we need. And the code also is so complex, you really can't hire an engineer and just send them in to work on a project like that. It takes years of experience to be able to confidently work on such a code base. So even though you have the source code for this component, it really isn't that useful. Having a source code isn't helpful in some cases. And so another case, we're running a scan-to-bin project where we're trying to process point cloud data. And we want to recognize walls, floors, windows. We want to recognize a building model out of a point cloud, and we want to generate an IFC model from that. And so there again, we started looking at open source components, and we found a useful library called Point Cloud Library, and it had some nice utilities. It had some implementations of algorithms for working with point clouds, but beyond the simple implementation. Simple is not the right word, but beyond the implementation of a few algorithms, it doesn't do what we need, and it isn't adaptable to solving the problem that we're looking at for scan-to-bin. So in our experience, even though open source is playing an extremely valuable role in the industry, it really isn't suited to solving highly complex problems. Our business model, we like to say that we're more open than open source, and I'll explain the behind that. So we don't just publish our source on GitHub. We've got a source available model. So what that means is that if you're one of our top tier members, you have full access to our source code. And there's some real advantages to that access that you get that you don't get from a normal open source environment. So the first one is that as a nonprofit, we fix bugs for free. So maintenance is no cost. So if you have any problems with our code, you tell us about it and we fix them. And just from we've been around for about 25 years, and we have 1,200 members, 1,200 customers that are using our product. And out of those 1,200, we've got probably 2 that have gotten into our source code and have done some work themselves, like fixing their own bugs and trying to make some improvements. everybody else, more than 99% of the people that are using our product, they want us to do all of the maintenance on the code. They don't want to touch the code because the source code for CAD and BIM products is really complicated, and it's not cost effective for them to get somebody trained to go in and be able to work on such a complex code base. They'd rather leave that to us. So bug fixes free with our solution. If you're working with open source, you may have to pay, you have to train somebody who knows how you're going to get a bug fixed. We have integrated visualization, so we have a full technology stack. If you're working with an open source IFC library and you're trying to do visualization, you're probably going to be going off into some other component. Now you've got another party to deal with if you're having any issues with visualization. Geometry kernel, same problem. A lot of open source IFC modules will try and leverage like Open Cascade. And again, I'm not trying to find any fault with Open Cascade. It's great that they've got an attempt to put a solid modeler together as an open source project. But we talk with a lot of vendors, and I've not spoken with one person who was happy. I talked to a lot of people that are using Open Cascade, but people are not happy with the level of quality and the support options available. And the only people using it are people that can't afford to license Parasolid or some other premium geometry kernel. We have our own integrated geometry kernel, so any problems with that part of the technology stack, we fix it and we take care of that. And the other thing that you get with our organization, the other advantage that we have is that you can get a membership, one of our top tier membership levels, and even as a small company for really a nominal cost, $18,000 a year, makes you eligible for a seat on our board of directors. So even a small company can come in and really have a meaningful role in directing the future of our organization. And you generally don't have such opportunities with a normal open source project. The other thing that we do as an organization is open toolkits for proprietary standards. And actually, this is our main business. The IFC is something we've gotten into more recently. But historically, the reason our organization was created in the late 90s was because the industry needed a solution for accessing DWG data, and there wasn't a good way to do that available on the market at the time. So our flagship product, if you will, is called Drawings SDK, and it provides full access to DWG, the data coming from AutoCAD. And so you can read, write, edit, you can publish, visualize, and everybody outside of Autodesk, I mean, I know some people are licensing Autodesk software for this, but we've got a very favorable licensing model, and so hundreds of companies are using our technology to access DWG. And between that and between the tools that Autodesk provides, DWG has really become a commodity. People don't think twice about accessing DWG, even though it's a proprietary format. Everybody has easy access to a nice tool set to do whatever you need to do with 2D drawing data. And so I'm definitely not saying that this is a substitute for open standards, but in this case, nobody's trying to put together a standard for 2D drawings because the data interoperability, the data accessibility problem is solved. So in some cases, a toolkit for accessing proprietary data can help the interoperability problem, even though it's not a substitute for open standards. And we get a lot of demand from software vendors for this technology. And so we have similar toolkits for Revit, for Navisworks, and other formats. There's a lot of demand in the industry for being able to access proprietary data. And I think that it's really sort of a parallel road that open standards are taking, and that the open standard initiative, in my opinion, is more important. This is not a good, reliable, long-term solution it's certainly not a replacement for trying to get data into open standards. But there's commercial demand for this. This is why our organization was created 25 years ago, and we thrive by providing primarily these tools. So this is another aspect of what we do. And it's an alternative solution in some situations for OpenBIM. And finally, I just want to talk a little bit about one other project that we're working on, ScandiBIM SDK. This is a technology that yeah, there it goes. So this project, we've got about 10 companies that are investing money for us to develop technology. It's taking a point cloud scan. You can see here in our viewer, and we go through and process the point cloud data, identify planes and other surfaces, and then go through and identify walls, floors. You can see now we've kind of got an outline of things from the building, and then we're going through stages where we're trying to refine this data. Here there's some junk like a coffee table, there's some ducting, some things that we can't recognize automatically yet, but getting rid of that stuff, and then we can connect the floors and the walls and really come up with a building model that represents the building that was taken, the scan was taken from. And so here you can see it's an overlay, the original point cloud scan along with the model that we generated. And it's not perfect at this point, it's an R&D project. So we're hoping to have something out maybe by the end of the year that's a little bit more complete. But the goal is really to provide straight through processing without any human intervention, where you take the point cloud and you get a BIM model out of this. And so we, from this point, after you've generated this geometry, then there's an option to save this out as an IFC file, and so here, saving it as IFC, and then you can flip over to our OpenIFC viewer, and you can open the model up. And so now you've got the rough IFC model in the viewer. Oh, thanks. So anyway, this is just one of the R&D projects that we're working on behalf of our members. All of our development is driven by our membership. So we get funding for a project if we get it's cooperative development from the industry. So we get 4 or 5 companies that are interested in a project. They all join forces and give us funding, and then we manage a team to solve the problem on behalf of the group. And so it's a lot cheaper than 10 companies trying to develop the same product all on their own. Everybody instead is cooperating through us, and we're developing the one good solution for the industry. So this is one of our new projects. And just a few quick conclusions. Key interoperability software, it has to have financial support. You can't expect these complex projects to be done by volunteers, but profit shouldn't be the driving factor. You need an organization like ours that's interested in developing software for the benefit of the industry and not doing it just for the bottom line. High quality toolkits should be available to everybody at a nominal cost. I think it's really important. If OpenBIM is going to succeed, then there should be really great software available to everyone, not just to the companies with deep pockets that can afford good tools and everybody else is kind of scrounging around trying to get something to work. Really good tool set needs to be available to everybody. Cooperative development is essential to the long-term health of the industry. It doesn't make sense. You have a complex project that everybody needs. It doesn't make sense for every company to be implementing the same thing over and over and over again. It's much more cost-effective and sensible for companies to cooperate at this low level of interoperability technology that everybody needs. And finally, just a little pitch for our organization, but one that actually I believe in very strongly. I've worked for this company for more than 25 years. We've got a really good development model suited for this type of development, nonprofit, helping the industry to work together, providing really high-quality solutions for the long term. So, thank you for your attention.
Thank you, Neil, for providing us this tangible example of how to get closer to the open source way of doing, let's say. Just one example, and we have more. But now also to expand to that standardization and also the impact of adopting it. We have Sandra Benson here with a short presentation titled Climate Change Mitigation with OpenBeam. Sandra is she's the Vice President of the Industry Strategy at Procore, as well as the board member of the National Institute of Building Sciences in the United States. So, yes, thank you.
Hello, everyone. As you just heard, my name is Sandra Benson. I do work for Procore. We are a construction technology software. However, I'm not here to sell it to you. There's no pitches here. I'm actually here to talk a little bit more about the why. So this is not a technical presentation. It's just a conversation. So I want to leave this here and wanted to tell you a quick story. You can look me up on LinkedIn. I have a fairly long history, but before joining the NIBS board in Procore, I actually ran, what was my title? Worldwide Head of Engineering, Construction, and Real Estate for a very, very large cloud provider that starts with an A. And at any rate, and that was fine, kind of a cool job to have. And the only thing we worried about then was cost and schedule, right? And for me, in the 30 years I've been in this industry, that's always been the question. What's more important? Okay, do I need to get this thing open, or do I need to, which one comes first? My argument, if you want to call it that, or my hypothesis, is by the time I finish talking, I hope that you will see that after all those 30 years of two things, we now have a third, right? And that's carbon. And so I never really thought much about it. The founder of this specific company actually started something called the Climate Pledge, which I'm sure many of you know. So we were down building our things. We had our own department, and really no one bothered us with the exception of cost for the most part, or schedule. And we figured that this particular company, most of their carbon would be in their trucks and their transportation and those kinds of things. And for the most part, for the first year, we pretty much were left alone. But then someone decided, wait a minute, we're building an awful lot of things down here. We should really look at the carbon. So the first was obviously operational carbon. I thought about bringing all that up, but I'm pretty sure you guys have already heard all that the last couple of days. So at any rate, operational carbon to a large extent is easier, if you want to call it that. I hope I don't offend anyone, but you can at least monkey with that a little bit more. Embodied carbon was something that many people at that time didn't even know about. And then the third piece is waste, which is a big one for me. Don't think we'll have time to get into it, but if you want to talk about waste over a cocktail, which sounds a little odd, I'm happy to do so. But at any rate, so with that being said, we were told that we need to start reporting on this. So there literally was a time where I had a project that we had to make the choice of going over cost and going over schedule in order to meet the goal of the carbon that we set out. Okay, so with that, I guess I should drive, huh? Okay, so I told you I wasn't going to talk about our software company. I'm not. And these are not all the tasks at all the stages, but these down at the bottom are all companies that to one extent or another provide environmental carbon type reporting. This is where open standards come in. This is where OpenBIM comes in. So as I told you, I won't get into the details, but this is what's important. And the open standards part of it is extremely important because I won't go into which one and have this or not, but several of them are not quite as open as you would like. So our customers come along and they want more, and we're not able to give that to them because their APIs are very limited. So, okay, again, not planning to tell you all this. You already know all of it, I presume. But this is the one thing I wanted to mention to you. You hear embodied carbon all the time, right? You hear operational carbon all the time. Waste, we found at this specific company, when we started tracking waste, we found that we really could make a huge impact. And it was an area that no one really focused on. So I would encourage you to do so. Okay, I'm not a big fan of people taking pictures of slides because I do the ugliest slides in the world. However, I love this slide. It's like my favorite slide of all time. And it's, this is actually just in here for fun, right? When we talk about embodied carbon, we talk about environmental product declaration, which always sounds pretty. So when I'm trying to talk to someone about that that's not in the industry, I love sort of the cereal box concept over here. So this, I just threw this in for fun and said we could skip it, but I use it in almost every presentation because I really like it. Okay, this is interesting. You don't have to read all this. It's blurry somewhat on purpose. So believe it or not, it was in the late 90s, early 2000s that I actually was involved with buildingSMART and these kind of things. We were talking about BIM at the time. Just BIM, not open BIM, just BIM. And the concept was, the theory was everyone will do it and life will be fabulous. And it would have been had everyone done that. There's lots of reasons why that didn't happen. But this is about 7 years old. Comes from one of the largest contractors in the world. You notice they don't have their name up there. And it's somewhat blurred on purpose. And that is that even back that many years ago, 6D was still there. I don't know about you guys, but we didn't really talk about it. We were happy if we had 3 and 4. And to be really honest with you, I'd love to show a show of hands if you want to do this with me. But I'd be really surprised to see how many of you guys actually truly on a day-to-day basis in your projects deal with 4D. What I see is it's very much used in the beginning, looks really good, but when you really get into the nitty-gritty, I don't see that. And I'll say the same thing with cost. I saw a couple nodding heads, so thank you. Because if one of you guys are doing all of these, I would love to hear it, please. But at any rate, so I want you to just think, I'm not even going to get to 70, which is something that I also like to talk about. But if you imagine the kind of decisions you could make if you had not just the data that's on the model, right, but also the schedule and the cost and the carbon calculations, you could make those kind of decisions that I brought up earlier. Make sense? Question? Okay. I always hate when I use someone else's slide and I have to blur it so you can't really see it. Okay, I'm just going to go through this really quickly. I'm probably out of time, but I'll go really quickly. And C&D is construction and demolition. We all know, I'm sure you've seen it and you've heard it already, adaptive reuse is something that is coming on more and more. So with that being said, I'm sure you may know these stats, maybe you don't. I found these stats to be quite amazing when I first heard them. And whenever I speak to almost anyone, they are like, really? So if you look at these stats, it's quite phenomenal, right? So here we are back to why we're talking about technology, open standards, these kind of things. Well, what's really interesting here is not just being able to capture that, but the part about what can be recycled and what can't, what ends up in a landfill, what doesn't. Artificial intelligence is one of the tools that will help us not only know how much waste we have, right? And in theory, we will begin to use that logic to reduce that as we continue to design and build. But more importantly, or just as importantly, it will help us say how much of that concrete actually did we recycle? how much of that steel did we? What's actually staying in the landfills? So that's where we think AI will come in. It's obviously just another tool, but again, just what I keep saying over and over, I don't like to think of myself as the waste person, but I really think if you focus on it, it makes a big difference. This is also an old slide. I wonder if I can find some fun ones. But here's the thing. I want to point out this right here. So even before Open BIM, and even before I knew I was coming to speak with you, I thought about changing the slide, but then I decided not to. And that is, if you really want to start eliminating waste, BIM, even of itself, even before Open BIM, would really help us. If you take that and imagine the future of what Open BIM can do, then you can significantly make a difference in the construction waste that we have in today's world. And so with that, I will leave it with you. If you have any questions, again, not the most technical, but hopefully it sort of answers the why. Okay, thank you.
Thank you, Sandra, especially for reminding us how much of we had probably initially planned a few years ago, still missing, and not achieved yet, but we will try and to accelerate it. And in that regard, Roger, he will tell us how we can probably, through the use of standards, accelerate it just a bit more.
Yes.
Roger Grant is the program director at the National Institute of Building Sciences as well. So thank you for coming.
Thanks, David. Hello, everyone. Great to be here. Great to see everyone. I'm just going to pick up on one thing that Sandra said. A colleague in Norway shared these statistics with me. She said, the building industry, we're the 40% industry. I don't know if any of you have heard this before, but it really stuck with me. 40% of the waste, she was a little higher than you, 37% of the carbon, 40% of the energy, and 40% of the materials consumed in the world belong to our asset class industry. So if we don't need a motivation to figure out how to be more efficient, maybe there's one. I'm gonna, try and share a few experiences from what I'm working on in the US and how they could be relevant. I'm just gonna, keep an eye on the time because I've got a lot of things I'd like to share, but I'll go through them quickly. Just to talk a little bit about my organization, what we're doing with open standards and how open standards support the idea of sustainability and workforce diversification and workforce development, open information sharing, because I think standards, open source are important, but an overlooked aspect is just how easily can you share information with your community, your constituents, the people you're trying to work with. I just want to comment on that briefly. And then just a little bit about innovation and what we see there in supporting what we're trying to accomplish. So the National Institute of Building Sciences in the US, we're a nonprofit created by our government. We focus on industry leadership and advocacy. So that's kind of where workforce development fits in. Security and disaster preparedness, dealing with crises and resilience, I'd put in that category. Facility performance and sustainability. I'd call these, the higher order things that we deal with, the big goals that we want to try and accomplish. The reason why we really are, trying to make things happen and make things better. And I'm going to focus on information and technology, the sort of foundation that we use to accomplish those goals. I don't think if we can't figure the information and the technology out, we're never going to solve the other problems because they're a little too big without some kind of assist. So we do a lot of work with the federal government agencies in the US, and that's a lot of the perspective I'm going to bring here. I think we all know that we've got to do a better job. So I just put that in there to make that point. I'll just talk for a minute, quickly about how we're trying to accomplish these things. We try to work with all aspects of standards, and I'm just going to, say we utilize international standards, of course, like ISO and IFC, although probably not to the extent that they're used in other parts of the world, especially the ISO standards. And I think that's something we need to address. We have national standards that we use extensively to try and accomplish shared practices, shared procedures, efficiencies. But even those we need to work with. We work with the buildingSMART suite of standards and adapt those for use in the US. I'll talk about that just a bit more. And then probably a lot of activity happens at the individual organization level, and clearly there's standards and requirements that they're issuing. We have model contracts in the US that drive a lot of the way projects are developed and delivered, and those are an important aspect of how we try to achieve efficiency. And also, thinking about these standards in the context of information management and information exchange, I think, is a useful way to look at them. So just thinking about information management standards, we've published a national BIM standard in the US that does attempt to make it easier, more efficient to deliver on construction projects to help achieve the kind of goals we want to achieve. We've developed a standard for owners to help identify for owner organizations, because getting owner organizations to issue the right kind of requirements is the start. If that doesn't happen, I think that's where things break down. And a lot of times we're not getting the kind of performance from the owners we work with that we need to really get results, make things more efficient and effective on delivering on those bigger goals. A lot of owners do have their own standards, and I think that's progressing and that's important. If you don't have your own standards and your own information in some kind of shape as an owner, using open standards is less effective for you, I think. And we don't have wide use of ISO 19650, this kind of umbrella standard in the US, but we're progressing towards doing that. We're ready to start working on adapting it to the US. We have done over the years quite a bit with buildingSMART, with IFC. I guess, IAI started in the US and we started developing IFC there. It's now, of course, grown to be a huge worldwide operation, which is fabulous. We have worked in the bridge domain, we have a lot of activity in infrastructure around using IFC and using that standard for information exchange. We've used it in buildings quite a bit, especially something called COBE, Construction to Operations Building Information Exchange, which a lot of people use to get information ready for handover. A lot of building owners require that. I think we still struggle a little bit with it. It's implemented in software, but we still don't get the kind of results we need. So we keep working on that and looking for maybe how we can work with getting the 19650 in place to give a bigger context for that and get our building owners to do what a lot of our infrastructure owners are trying to do now with using IFC. A few examples are what's going on in the bridge industry in the US. We've had an effort to develop IFC as the required standard for delivering bridge models in the US, and that's gone into its second phase and is working with vendors. We're starting to see the state departments of transportation implement that standard. Another example of utilizing standards is in work we do with our Department of State. We use a standard set of BIM uses that we can then use to organize their whole planning process for how they manage their information flow and how they work with the different suppliers that they have, and then those can develop use cases and user stories under those, and that's been an effective way to structure this large organization's implementation of technology. And then they use that to develop requirements that they can then issue to their consultants. So again, having an owner have their information and their requirements sorted is important. Whether they're open standards or in-house standards, as long as they're shared, that's critical. The other thing they do is use COBE to deliver information across the project lifecycle, and that's getting them handover information at the end of construction they can put into their computerized maintenance management system, and that's the process is in place. We struggle to get the results, but we're getting better results all the time from that, I would say. So that's a little bit on open standards. I just wanted to put the perspective about sharing information out there and doing that as openly as possible. Except we have a little issue from the government perspective in how you can share information. we have something called FedRAMP, the Federal Risk and Authority Management Program, Authorization Management Program, which every federal agency for any cloud-based service, it has to be FedRAMP compliant if it's going to be used by the federal government. So software vendors have to go through the process of getting FedRAMP certified, or you can't put information on the cloud and share it for the federal government. And this issue is, they have sort of a very specialized perspective on it, but it really permeates the industry. I think the problems of information sharing are really an important thing to consider. And we did a workshop on this, wrote a paper you can find on our website, nips.org, that describes this, and we hope to do some more work in this area. Just a couple of examples of some things we have done that are interesting in sharing information. Our defense and veterans health systems in the U.S. Build the hospitals and care facilities for the military and veterans. And we worked with them to take all their requirements that were in PDF documents that said, oh, here's what you put in a dental lab or in an operating room. And we extracted all the information out of the PDF, put it in database, created models that could be used by the designers to plug into their designs. And the VA makes it all available on their information library. So any one of their consultants can come in and access that, and anyone around the world can access it. It's freely available for use. And it's not on the cloud, so they don't have to meet the FedRAMP requirement for issuing it. There's also some private software that's been developed that allows you to plug in to a system. We work with Enuma extensively on a lot of different projects, and this is one, and they've developed this separate BIM. You can then extract the requirements out of that system and put it into a model and ultimately deliver what's in that room that's been identified in that facility back to the VA. So this concept we've used with other owners as well. Another success story we have is the State Department uses a secure Google Suite application that we can put data on and share with all the consultants that supply them. They have to be members of this network, but everything can be shared. You can have a single source of truth for your information then that you can make available through this. And that's allowed them to set up a system where they define the spaces in all of their facilities and all the components that go into them. And then they can track that requirement all the way through from planning to the end of construction and operations. And in this way, we're making the process more efficient, more open for that community, and we're achieving more efficiency, we believe, by doing that. So that's an example of how this open sharing can be important. And I guess this is sort of just conceptually what we're trying to do with standards is to go across the whole process, use standards and open source, some of the open source ways of delivering information to have this common environment where you can identify the different things that you're trying to accomplish and use security controls at the appropriate level to work with large clients. That's really important. And so this is kind of a conceptual model of what we're trying to do to make information sharing available of all kinds across the whole life cycle. I'll credit Kimona Numa for helping to develop this idea. I just wanted to touch on, in the last minute or so that I have left, how we're also trying to explore what we can do with new technologies, other technologies, to help us address these bigger issues and come back to the point about sustainability and carbon and workforce. So we're trying to work on this idea of BIM and digital twins. We think there's been, a lot of certainly conversation, but also confusion. So in conjunction with the Digital Twin Consortium, we have a work group that's developing a definition here, a white paper that's going to be published anytime, and maybe that'll be helpful to industry. We've also started to explore AI. What can we do with AI? One interesting application in the US is our code. We have a national code that's published by the International Code Council. They've developed an AI agent to search across that and bring information out of it and make it more accessible and usable. a company you've worked with a lot. There's a lot of generative design applications, and a company in Norway we've worked with a lot has an MEP optimization application that looks pretty interesting. Our partner Anuma, again, has worked with the California Community College System to take data that they had available and is issued publicly and use AI on it to develop some conclusions from large data sets. So these are things we can do by applying these technologies. We've done a workshop on this, and you can get some information about that from our website if you're interested. We're trying to keep exploring this topic. But I will just still make the point, these are cool things, but it's still about the data and the foundation and the platforms that can help you apply those things. So one last thing, to come back to this point about sustainability and diversity, we've tried to launch in the US a national program that would let us address the issues of workforce, of sustainability, of efficiency and effectiveness, a national program of standards and shared practices and procedures that we're trying to use to accomplish these challenges. So thanks, and you can find out more about this at NIBS, and I'm sure we'll talk a little bit more about it. I think these things will be available in the presentation also.
Sure. Okay. Thank you, Roger, especially for showing us how we really can share our industry outcomes in a more, let's say, efficient way, especially all this work that you have been, not you, all the, in this case, United States, been doing during many years, and how we can keep doing it, but in a more efficient way, let's say. So now it's the turn of Antonio. Antonio González Viegas is the creator of IFC.js and Chief Executive Officer of that open company. So, your turn.
Okay, thanks a lot. So, hi everyone, I'm Antonio, and I'm going to try to be fast. So, I'm going to explain you super quickly who I am, what we are doing, and what we are trying to achieve with that open company. So, I am basically a regular architect. I was born here in Spain, in Sevilla, a city in the south, and I started coding 4 years ago, more or less. So that's everything probably that you need to know about myself. So what we are trying to achieve with that open company, we are trying to open up the market. And what does this mean? So, from a programmer perspective, any software is just a number of lines of code. So basically text, instructions to the computer, any software that you use, from the mobile phone to the video games, anything, right? So for instance, take a look at, 3JS, the most popular graphics engine out there. It's more than 50,000 lines of code. Almost 2,000 people contribute to this open source project over 10 years. This is it. It's fantastic. We are using it, right? So what about BIM software? Because if we take a look at BIM software generally using this lens of lines of code, how many lines of code would I need to make a BIM modeler, the BIM modeler that you use in your day-to-day life, right? So probably you would need a graphics engine that allows you to display huge amounts of data efficiently, even in not so powerful computers. You would need a geometry engine that allows you to make a click and suddenly you have a hole in the wall, performing the Boolean operation and putting or having two walls like this, and then you solve the encounter, right? You probably would need also UI elements that allow you to basically build the whole set of menus that your modeler needs. Error management system, MEP, HVAC, all the things that you use in your BIM application is nothing more than a set of pieces, and in the end, are nothing more than a set of lines of code, right? So this is more or less the situation in our industry. We have a number of applications that are great, but the problem is that they have been around for, in my opinion, a long time, and that means that they have many, many pieces, and that means that new players have it hard to get into this market, right? It's like saying that each car company has invented the car from scratch. So in order to get into the car market, you need to invent the car yourself from scratch, which is, of course, super hard. So what can we do about this? We have taken a reference in other industries. And in fact, I'm a very avid video game player. So I bring you this game today. Hollow Knight, video game, also a software, so it's also made of lines of code, right? Fantastic game, physics engine, real-time graphics, visual, fantastic story, design, everything. So again, this game is just another piece of software. So let's take a look at the numbers for this. This game was done by 3 people in just 4 years. I haven't seen the source because it's not open source, of course. And these are the numbers that this game made in the market, right? Of course, it has been around for a long time, but in net revenue, it has done almost $60 million in net revenue. If you can see it here, and you can check it, it's all public, right? So why can't we do this? Why can 3 people in 4 years come up with an alternative to whatever Bing application you can come up with, right? So the secret, it's not that they are smarter than us. I think that they just have better stepping stones. So the secret is that they don't start from scratch. They have something that is called video game engines. And video game engines are nothing more than the hardest pieces that you need to build your game already available to you so that you can focus in just what adds value to your product. Because to be honest, nobody buys Hollow Knight because of the physics engine, because of the graphics engine, because of everything. You buy that game because of the story and how it makes you feel as a player, and and usually these pieces, which are the dream pieces on the right, are the easiest pieces to develop, right? In this case, it was done by using Unity, but I mean, there are many options for video game engines out there, right? So what if we go back to this view and apply the same lens? Because the way we see it, in the end, most BIM software has a relatively big maximum common denominator that everyone needs, but no one is really selling, right? You always need a graphics engine, you always need a geometry engine, and all kind of things. But in the end, you don't use a specific BIM modeler or a specific architecture because of that. You use it for other things. So the idea is that what if we had this, what I call maximum common denominator available? Probably that would mean that suddenly a market that has a super high entry barrier would be super easy to compete for new players, right? Now we are seeing a boom in content, construction technology startups and property technology startups. And I am very sorry when I meet the founders, because I always find that they are trying to start from scratch every time, and it makes it super hard. I don't know. I know at least 3 startups that are trying to make an online-based modeler, a BIM modeler, and I think that each one of them has between 5 and 10 millions in investment, and they are individually creating a geometry engine from scratch over and over again. And it's sad because in the end, they are not going to sell that geometry engine. They are going to sell something else. At least that's not the reason why their clients are going to pay them, right? So this is what we are doing in that open company. We are building that maximum common denominator of pieces in an open source way so that anyone can start not from square one, which is the current situation, but they can start from where we left, right? So instead of trying to go very far away, we are trying to simply push the square one as far as we can, so that getting into this market and competing, even as a small company or even as a company that doesn't develop software as the main business model, can compete on a level playing field. The way we are doing it is really simple. Basically, we are building this from the community or people perspective, and also from the tech perspective, of course. We have created a community of people that, just like me, come from this industry and have getting into programming. This community has, I believe, like, I don't know, 4 months old or 5 months old. We have over 4,000 people in there. People that, just like me, started programming one day, civil engineers, architects, even software engineers that are attracted by whatever reasons to our very special industry and want to get started or follow the same path as I follow, right? And from the tech perspective, of course, this is not an easy task, but we are doing our best to basically build all the pieces that literally every player needs, but no one is really selling directly, right? So yes, I don't want to bore you a lot with this, but I'm going to skip super quickly. So we have a powerful viewer that can display huge amounts of geometry directly on browsers. By the way, all these that I'm going to show you are open source libraries, MIT, so that anyone can use them and build on top of them, even for commercial purposes, limitless. Yeah, huge amounts of geometry, even on mobile phone. We have recently developed a streaming system that allows to open many gigabytes of IFC in seconds, even in a modest phone. This is an IFC model that has the whole city of Zurich, I believe. It was like 2.7 gigabytes opening in my phone, which is not an iPhone or anything, right? Yeah, this is a small experiment that I did one afternoon using our technology, creating a Beam viewer directly inside Twitter. This was super stupid, but basically just using a Chrome extension that embeds the 3D viewer directly inside Twitter so that anyone with the extension would be able to see the model in that specific tweet. This is just a very small example, but just showing the possibilities of what happens when we start building software instead of being just mere end users, right? This is another example doing a similar trick, embedding 3D BIM models directly in SharePoint using free and open technologies, of course. Everything is IFC. And this is the same for Microsoft Teams, right? In the reality is that nowadays, more or less all the big software companies have open APIs so that you can get really, really far just using the free software that they provide you with. Yes, we are also covering infrastructure. We can open IFC4. We are collaborating with companies so that we can help them build the software that they need to manage their civil projects. We also are building a library for UI components that allow anyone to build basically applications that look like this within minutes, right? And even allowing to edit everything using the code. And yes, we are also building a modeler. We are releasing this summer because someone realized that, hey, we have a viewer that has a geometry engine, by the way, it's open source. And what if we turn it upside down and we use it to edit things in real time? And yes, it performs Boolean operations in real time, of course. This is a super basic example that I did like 1 month ago. We are much farther away today. And the idea is that this summer, anyone will be able to use this library to build their own modeler and even not only create, but also edit any IFC file natively, just having the native experience, right? But again, we are not focusing the end users. We are basically creating the pieces so that anyone can get into this BIM software development game. So this is it. I think that I made it in time. So yeah, thanks everyone.
Thank you, Antonio. Now it's the turn to start a discussion around all this background. We've seen many things from different perspectives, and now it's the time to, well, let's try to start building a message for the end of this session, starting a discussion here. And I would like also to get you here with some interaction with them, but I will start. So I have like a double question because we have like two sides here, and it's trying to combine both concepts, right? So do you think that open standardization can take advantage throughout the use of the open source in order to increase its impact? Because in the end, we have some, as Clive shows us, that pyramid, in the end, we have some sustainability goals, and we are all here doing things for high-end purpose, right? So do you think that examples like these or what Neil showed us can help so in order to achieve those goals faster, or at least as fast as Antonio talks? Feel free to start. Roger, Neil.
Somebody want to take Neil?
Maybe you should.
Yeah. Use take this if you want.
Yeah, sure. I mean, for me, open standards is just one of the two legs that you need. Open source, or at least available software, is the other half, because yes, IFC is fantastic, it's open source, but if you don't have abstraction layers or software built on top of that standard, it's just very hard for new software developer players to get into the game, because developing an IFC parser is not easy, developing a geometry engine is not easy. So I think that it's great that we have many options of software built on those open standards. So in my opinion, open standards are necessary, but we also need software projects on top that allow people to build things without starting from scratch each time.
Yeah, I just wanted to say, interesting presentation from Antonio. And we're actually trying to do a lot of the same things that they're talking about, trying to build up a set of components that everybody can use and get access to without having to reinvent the wheel over and over again. So I'm really impressed with the work that you're doing and wish you the best of luck with some of these components because they're quite complicated. And we definitely should be in touch because if you have success with some of these things, we're certainly open to partnering. We're certainly not anti-competition or anything in that way. So I'm really happy to see what you guys are doing and the engagement. What did you say the numbers? How many people do you have?
4,000 so far.
And your revenue? What's your revenue model? That's
So maybe I.
Sure.
Or maybe
They didn't know each other before.
So thanks, definitely yes. We are up for collaboration. We also don't believe in this, competition thing, which you don't even to look to the person, if it's your competition, because in the end, the truth is that we are probably facing similar problems, and in my opinion, it doesn't make sense to solve them over and over again. Very specific problems like how do you solve coplanar linear operations in geometries that are very far away from the origin. That's a very specific problem that is a pain to solve, and it doesn't make sense, in my opinion, to just solve it twice, let's say, or Boolean operations in general. And I see they are difficult, right? So answering the other questions, the company is 5 months old. We are bootstrapping, we have investors. We have made $500,000 in revenue, more or less, just using the community, teaching people to code, and now we are probably going to start releasing some services, and the idea is that we will probably become something similar to MongoDB, in which we have the open core, but people that don't have the time, the willingness, the budget, or the whatever to do it themselves, they can just have a plug and play something that they can maybe available source like YouTube or something like that. But yeah, we're learning. We are super young, just 5 months, so I think it's all humbling.
Yeah, no, it's great. It's great to see.
Great. Okay.
Yeah.
From the standardization side, let's say.
From the standards perspective, I think, this is all great to have open source as a way to leverage the standard. I think we still need underlying standards, and they should be complementary such that they would make the open source development more efficient and more effective if it has good things to point to build on top of. So I think, it's a good situation for achieving the bigger goals if we can make software development happen more quickly and more incrementally, then that's a great outcome, I think.
So coming from a software vendor side again, one of the things we really think would help is we know there are critical workloads, right, that, just have to be done. And to the extent that we could have some standardization on those workloads, that would be extremely helpful for us. So that would be something that we would ask. I realize that's challenging because of openness and collaboration and even contractual issues. But for me, in order to move this forward at the rate I think we want, let's figure out what those critical workflows are and see where we can go from there.
Thank you. Do we have that? Someone from the attendees want to jump to ask them things? Yeah.
Thank you, Daniel. I was attracted by the AI mentioned in the summary of this session. But we didn't really heard a lot of it. Now, just recently, a new version of an AI named Claude version 3 was tested by experts, and it was better than any other. But that's nothing really new. Every new version of any new AI is mostly better than the others. But what caught my interest was that this specific clause found out itself that it was tested. I don't want to go further because I think you know what I mean. AI can know much more about the environment where we use it than we can think of. And my question to you is, do you think we are actually aware of the power and potential of the AI in our sector?
Nice. Open the gate.
Some comments, I can't speak on behalf of the sector, but for us, it's a priority company-wide. We see huge potential. We've been trying to use some AI coding tools, and I don't know, it's, the results so far have not been good. I mean, we see a lot of promise, but like we had a meeting and we're looking at some of the code that this AI thing had written, and our guys are like sitting in the room all laughing because it was supposed to do some simple geometry operation and it just did some nonsense. And so you can't, we're looking at it at this point as a way to maybe save some work on routine tasks, but we don't see it in the near future being able to solve complex problems. But on that, like the marketing side, stuff's already really good. I mean, like you write an article, and I was kind of humbled, you know, we were trying to write some articles for the company, and then my marketing team is like running it through the AI and giving it back to me, and it's like, oh, this is a lot better than what I wrote. and it's, you know, but it's, so I think the tools on that side are pretty good. But yeah, we absolutely see a huge potential, and we've made it a company-wide priority, but there's a long way to go to get to the point where we're really getting maximal benefit. But it's growing so quickly. I think you have to pay attention right now because you know what we have today versus what we're going to have in a year is going to be a huge difference. So yeah, I think people are aware and really taking notice and trying to figure out how to leverage.
Yeah, someone else want to expand it?
I think we're trying to explore what we can do with it. I don't see your question. We don't know what the impact is going to be. Clearly, in ways to iterate over design, it's really exciting to see how we could do small things many, many times over and then make something more efficient and use less materials. And I think those are all very promising. And the ability to analyze data, large amounts of data, and generate results from it and learn in the process is really exciting. We haven't done enough in my experience yet to understand how to make applications, but I'm sure it will happen, and I don't think anybody thinks otherwise, that we will have to figure it out as we go. I don't know, Sandra, you know, it's your company, you're a big technology company, so it must be an important factor.
Oh yeah, this put me right there. So it is an important factor. And as I think I mentioned before, we think of AI as another tool in your toolbox right now, but ultimately as a stakeholder. So it's a continuum, I would say, in that regard. Ironically, we work primarily with our customers, obviously to see what they're looking for. We do see a lot of data is in the field, if you will, not so much in the design, but in the construction, IoT data and that kind of thing. We do see AI really bringing benefit there. Haven't seen so much between this side and that side, if you want to follow the design into construction. But the ironic part of it is a shiny object, and it's great, and yes, it's going to happen. We sit down with some of our largest customers, and they want it, but they also have just fundamental processes that, you know, so we kind of have two halves. Some are like, look, we can't solve this, and others are like, let's move over here. So I think that's just a perception, you know, where people are on that continuum. Don't know if that answered your question, that's how we look at it.
I was just interested in your view.
The way I see things, AI is a multiplier, and the way I see it, our technology is 1 or 2 decades behind the technology we have in our industries. So yes, sure, AI will solve many problems that are hard to solve with traditional coding. But I think is not going to be the shortcut that allows us to jump forward the 2 decades that we are leaving behind. So for me, it's not like one thing or the other. We need to solve the technology problem, and then the AI will give us more power, right? But if you have a multiplication and your left side of the multiplication is a low number, no matter how big your right factor is, right, you're going to always be behind in comparison to other industries that have better technology than we do. To give you a specific example, in Holland, an individual game made by 3 people, they have flash detection 60 times per second, and in your industry, you have to press one button and wait some time until you get the flashes, right? So I think that AI, I hope that it did. I hope that today I could ask AI, hey, can you reverse engineer in this application? And he gives me a whole code. That would be fantastic because it would make my life much easier. But I don't see it happening. I hope it will happen someday. But I will just work with the assumption that it's not going to be a shortcut. We need to solve both things.
Well, just to add something that maybe is shared in this emerging, let's say, new technologies as well, artificial intelligence, just up here in front of our faces, it seems. So, but I think that it's about reliability, let's say, and especially also the ones from the open source side. Do you think that there is some in our industry some kind of reliability fears embracing or start using the open source? And of course, once we even add another layer of technology such as artificial intelligence, then it's even the fears could even increase. But do you think that this is something that we still have, or? And it's a question not just for you, also for probably the ones that are not exactly deeply on that side.
I think that open source comes in many flavors. Sure, you can think of open source as an application made by a bunch of guys that have weird hobby that is slightly worse than the enterprise solution, but you are encouraged to use it because it's cheaper or it's morally correct or whatever, right? But nobody doubts on the reliability of MongoDB, which is the biggest non-SQL database service provider. And I think they have multi-billion revenue generated, right? And that's also open source in my opinion. Or Unreal Engine is not open source, it's available source, which is different. But Microsoft has many open source projects, many big companies also do. I think that the open source is just a feature that is orthogonal with reliability. Depends on the project you're talking about. And in my opinion, sure, you can have a project like MongoDB that has open source and is 100% reliable and enterprise friendly.
Mm-hmm. Neil?
Yeah, I don't think you can't categorize open source altogether in terms of reliability. And some products are reliable and some aren't. I'm worried every time I update the OS on my Mac whether this stuff is going to work properly afterwards. And actually, in recent years, it seems like the quality of Apple, across the board software, there's problems. So I think there's fear about reliability even with commercial software. It isn't something that's limited. And some open source products work really well all the time, and some of them don't. It really varies. But it's not. You can't just categorize open source or whatever in those terms.
Well, I agree with you very much that it isn't a one-size-fits-all, and some is reliable and some isn't. I think there is still an issue of trust out there. Yes, we see that, and yes, but it's a yes, but. I guess I see quite a bit. I do think that there is the open, the trust as well as security. And we haven't really talked about a lot, but that is still something that when there's fear, that's where I hear it, is usually in the security side.
Some other questions? Yeah.
Thank you for the presentations, they're very impressive. Because there's now a lot of technology point of view. I was just thinking, what do you think of the challenges we have in the future when it comes to the user demands? Is it changing? Do users ask for other kind of use cases or other user experience in software? You just think also about that kind of question.
I just want to make sure I heard that one correctly. I apologize. I think I got it, but.
Now, if you look at the future, you can think about new technologies or what can AI do for application development and so on. But what about the users? What do you think about user experience? Do you expect a better experience of software usage, or is something you are also looking for? And what are the trends, the futures about that?
I may be able to answer this one, at least from my perspective. Yeah, I mean, once upon a time, all of our systems on-prem were what I call coding, right? And we needed a book on this, right, to figure it out. In today's world, it needs to be quick, intuitive, that kind of thing, and that has been a challenge. But it's a mandate, I guess at this point, it really is. And we are seeing, we provide our software for free to universities and trade schools. And the reason we do that is that we want people to come out of school already, walking in the door, having at least some idea, whether it's our software or someone else's, but the concept of that. And we found that is, as you know, we've got a huge worker shortage, right? And we've got a silver fox syndrome, retiring people, and we have the new people, and then there's this gap. So, yeah, I think your point is very valid, and it's going to continue. It's got to be easy to use. It's got to be as easy to use as Roger's phone, to essentially say.
Maybe just add a couple of comments. One trend we see is bigger and bigger data files and data sets being used. And some of the data sets that people expect our software to be able to visualize, they're just enormous. And it's like we never even thought of anybody would ask about such a huge thing, a few years ago. So that trend seems to be increasing. And maybe one other trend is that moving to the web technologies, the technology that's supporting the web, like the visualization and things, is advancing really quickly. And so if you're a software developer and you're trying to maintain the viewing technology on the web, that's like evolving every year or two. You're starting over with this new technology base. It's totally different than how when developing on a desktop is a much more stable, long-term process. So the evolution of software, the development cycle is so much faster today. People are wanting, we release all of our products every month, because we have customers that are doing the same thing. They need fixes. When we started 25 years ago, it was like one release a year, or maybe two. And now, if you're not doing it every month, you can't compete. Everybody's expecting very quick. So the trend speed is very much a trend nowadays with the software development.
So, of course, management is super biased, but one of the biggest trends that I'm seeing is that the line between end user and programmer is becoming more and more blurry. Like, initially I was an end user, just an end user 4 years ago. Now I code all day, and I see many people in LinkedIn getting into visual programming, Python, JavaScript, and other languages, and somehow building smaller applications. And I think that identifying that the S of software also should be one letter in our industry, that A come with an S at the end of software. That is a trend that is good. I mean, maybe it's because LinkedIn just showed me what I like, but I think it's getting more popular, right? Getting into coding and becoming a software developer.
Well, so I think that we have arrived to the end of this session. So thank you all for sharing your thoughts on. I think that we have just digged a bit of the surface of all this huge set of topics here, and we can keep discussing it throughout the whole summit, let's say, and now you can reach them quite easily, and you can start a new, as we saw, relationship between people that didn't know before this session. So yeah, thank you very much to all of you.